Hi everyone. So today I had hoped that we were going to get to class learning about investigating writing an exponential model, which I really find to be the fun stuff that we're working with this year. So let's suppose you start a job and you make $40,000 a year and you receive a raise of 4% at the end of each year. Let's figure out how much you'd receive after the first year on the job. Well, there's a number of approaches that you could do there. You could do 40,000 and you could multiply it by 0.04, which is 4% as a decimal. So I'm going to do that. So 40,000 times 0.04, and that gives me 1,600. And then you could take the 40,000 and add the 1,600 to it, giving you 41,600. Okay, that's one way. That's like I call the long way, right? Or you could do 40,000 times 1.04. Okay, so if I take 40,000 and I multiply it by 1.04, try that on your calculator. What you should get is 41,600. Okay, first of all, I'd like to break that down. Why does that work? Why is it by adding 1? Well, some of you may have remember from pre-algebra that by multiplying by 1, you're including the 40,000 as well as the 4%. The reason that is if I break this up, isn't 1.04 the same thing as writing 1 plus 0.04? Okay, and so if I did that, it would be 40,000 times 1, which is what we did here. Which is what we had here. And then it's doing 40,000 times 0.04, which is what we did here. And then it's adding them together. Okay, so I want you to see that breakdown. Okay, so then how much will you be making 2 years on the job? All right, well, you'd have to take that 41,600. We'll multiply it again by, we're going to do 1.04 this time. Let's see what we get. $43,264. Okay, so you'd have to go you need the first year to get the second year. So how much will you be making 10 years on the job? Well, wouldn't I have to do 3 years, and then 4 years, and then 5 years, and then 6 years, and then 7 years, and then 8 years, and then 9 years? I'd have to actually get the previous year to be able to get the next year. This is where exponential models can help, okay? So if I want to know how much I'd be making n years on the job, I can take that initial value I started with, 40,000. We multiply it again by 1.04. But instead of multiplying by n years, I raise it to the n years. Because what that's basically doing is saying I'm going to take 40,000 times 1.04 to whatever power is the number of years. So I could say n years, I could say to the t years, and that we call an exponential model. Now, if I made it look like this, you should see how it relates to y equals a b to the x power. Okay? All right, so here's your lesson. That was what I really wanted you guys to investigate in class today. I'm sorry we ran out of time. But we're going to look at this as an exponential model, okay? So when a value is increased or decreased by a percentage, the function is going to be exponential. Because a percentage is a decimal is a fraction is a ratio, and we've said that exponential models go up by a constant ratio each time. And it can be modeled by a function in the form, okay, so I used function language, a of t equals a sub 0 times 1 plus or minus r to the t. So let's think about what we did. We did 40,000 times 1 plus 0.04. That was our rate. So this is our rate as a decimal. Oops, I can't spell today. And what was a sub 0? That was the 40,000, the starting amount. So we call that the initial value. And you know from our work with the graph that that's this y-intercept, right? And then we'd raise it to the t power, so that would be the time in years. Now, r could then be negative. We would do 1 minus if the value was decreasing. So increasing, we'd add r. Decreasing, we'd subtract r. Okay, so that's our model, and that's the model we're going to be using for word problems. All right, so let's look at an example. Now, we're going to talk about this alternate form in class, okay? So suppose the cost of a hamburger is $4 and has been increasing at the rate of 9% per year. Use the model above to find the cost of the hamburger. So first, we're going to write our function. So I'm going to use cost. So when we write these functions, I really want us to get used to using the variables that make sense, not just f of x. So I want to find the cost at t times, so I'm going to do c of t. So c of t, well, the initial price of the hamburger is $4. It's increasing 9%, so 1 plus 0.09, which would be 1.09 to the t. Okay, all right, so now what would the price be 5 years from now? We would do 4 times 1.09 to the 5 power, okay? All right, so now we do 1.09 raised to the 5 times 4, keeping it on our calculator, so it's approximately $6.15. That's a lot, isn't it? 9% a year. Okay, now remember this model is in years. So if it says 18 months from now, that's a year and a half. So that would be 4 times 1.09 to the 1.5. Okay, so 1.09 raised to the 1.5 times 4 gives me approximately $4.55. Now I also could say 2 years ago. So what would t be? T would be -2. Let's see if we can figure out what the price was 2 years ago. Now, mathematically, remember that means 4 times 1 all over 1.09 squared. All right, so I'm going to do that. So it was approximately $3.37. All right, so that's the exponential model that we're going to be using for real life examples when things go up or down by a percentage. Hopefully that was a helpful video. Have a great day.